What is up, Simpsonites? Welcome to another beautiful Sims Science Sunday. I am sorry I didn't put out any videos yesterday. I was mad busy, but we back at it again. Going to bang out this periodic table midterm study guide review sesh, okay? So I'm going to write most of these answers sorry, I'm scratching something on my screen. I just realized. You see that? So I'm going to write most of these answers probably shorthand-ish, but just be listening, make sure that you are understanding, make sure you had the right answers, and if not, try and figure out why, okay? So let's talk about hydrogen. How many valence electrons does hydrogen have? Well, hydrogen's configuration is 1s1, right? So this is the energy level. It's the only energy level. It's the outermost energy level. We have 1 electron. You could also do this by looking at the periodic table, seeing that hydrogen is right there. It's in the first group. Everything in the first group has 1 valence electron. So the answer here is just 1. Okay, which group of metals also have the same number of valence electrons? What properties does metals have and why? So we're talking about the first group on the periodic table. Go back down here, talking about the first group right now. So those are the alkali metals. Alkali metals. Okay, so they all have 1 valence electron as well, and they're very reactive. Okay, and that's the case because they have 1 valence electron. So any alkali metal that has 1 valence electron is going to have 1 outermost electron. So, for example, it would be 1s1, 1s2, 2s2, 2p6, 3s1. All right, so this is the configuration of sodium right here. Third energy level, 1 electron. If it gets rid of that 1 electron, if it reacts with something else and gets rid of this, then it has 8 valence electrons in its outermost shell. In the second energy level, it has 8 electrons. So that's why they're reactive, because they have 1 valence electron, and by getting rid of that 1 valence electron, they will then have 8. Okay? Then there's the other physical properties of those metals as well. Second group, the alkaline earth metals. The alkaline earth metals. Also metals, and then what kind of ions do they form? So if you look at this group, now we're talking about the second group right here. What kind of ion does it form? So what does it want to do with its valence electrons? Well, similar thing to what the alkali metals want to do. It wants to get rid of its valence electrons. So if it has nucleus, if we're talking about the third energy level and the other ones are full and it has 2, if it gets rid of that energy level completely, then it'll have a full valence shell. So it wants to lose 2 electrons. And if something loses 2 electrons, it's going to form a -2 ion. Okay? So like beryllium -2. Oh, I'm so sorry. Scratch that. Okay, it's losing 2 electrons. Okay, losing 2 electrons. So an easy mistake to make that I just made is thinking losing -2, but it's losing 2 negative charges. So if something had, let's use beryllium as an example. It has an atomic number of 4, so it has 1, 2, 3, 4 protons, 1, 2, 3, 4 electrons. But now it's losing 2 electrons. Lost 2 electrons. Now it has 2 more protons than electrons, so it's going to be +2. Okay, so a +2 ion, beryllium +2. Metals form positive ions because they want to lose electrons, therefore becoming more positive. So don't make the mistake I just made. The D block is transition metals. These are all the metally metals we think of here. So like zinc, copper, nickel, cobalt, iron, gold, all those like metally metals. When you think of a metal, usually a transition metal is going to come to mind. A group with 7 valence electrons is technically the 17th group on the periodic table, and it's the halogens. And they're reactive because they really want to gain 1 electron. Because they have 7, all they need is 1 more, just 1 more. So that's where we get sodium chloride, because sodium has 1 valence electron, chlorine has 7, so it really is pulling hard to get this electron, and this electron really wants to go away, so it works out, and you get that. So they're going to form a -1 ion because they're gaining 1 electron. But that's why they're so reactive, because they really want to gain an electron. A reaction is changing electrons. And the noble gases have 8 valence electrons, and they're not reactive because they have a full octet. They don't want any more electrons. They have all the ones they want, so they're not going to lose any. They don't want to gain any. Okay, metals. Where are metals found on the periodic table, and what are their properties? Where are nonmetals found, and what are their properties? Okay, so metals, if we draw the staircase here, that I believe, I don't want to mess this up. Off the top of my head, it goes here. Okay, and then I think it skips 2. But either way, I mean, these are generally metalloids here, and then everything on this side is metals, and everything on this side is nonmetals. Okay, so I know I didn't do a perfect staircase here, but it's not that important to remember exactly where it goes. Just know that pretty much everything to the left, except our exception is hydrogen. This is a nonmetal. But everything other than hydrogen on that side of the periodic table is a metal. Everything on this side of the periodic table is a nonmetal. Okay, and then on the staircase here, this general area, you get a lot of metalloids that can display properties of either. So metals are malleable, ductile, they have luster, conduct electricity, all that stuff. And all this is because of the sea of electrons. So what holds together metals and metallic bonds that we talked about the other day, sea of electrons, is what gives metals these properties. Nonmetals, we just talked about where they're found. These are oftentimes gases at room temperature or liquid. They have higher electronegativities, and all that sort of stuff that you can see in your notebook if you need to. But nonmetals, they tend to form covalent bonds with each other or ionic bonds with metals, things like that. Metalloids in the middle have properties of both. Okay, how does the development of the periodic table collaborative, an example of the scientific method in action? Well, they were building on the info that came before them, all these different scientists we learned about. They were looking at what was developed before, they were adding to it, they were changing it, things like that. So they were analyzing the data and putting forward their own hypotheses or building upon what came before. So that's how science can be collaborative and work together. Who was the developer of the most modern? So we're talking about Mendeleev here. Mendeleev, however you want to say it. And he left spaces for elements that hadn't been discovered yet. So everyone else was kind of trying to jam everything they knew into one periodic table. And Mendeleev kind of stepped back and he's like, wait, maybe we just haven't discovered this stuff yet because there's stuff that should be lining up that's not here. So he left spaces that we filled in, and that kind of allowed us to use his periodic table as we continue to go on. And he was organizing them by properties and atomic mass, atomic number, things like that. And now we still do that specifically by atomic number. How were elements ordered during the periodic table's founding? How are they ordered now? That's what I just touched on. They were organized by properties and atomic mass, which works for the most part, but now we use atomic number specifically. So for those of you who may have forgotten, if you look at the periodic table and you look at the numbers 1, 2, 3, 4, 5, it's by 1, and the atomic numbers is the number of protons. So we're increasing by 1 proton every time, and 1 electron for every neutral atom. I'm just going to erase all this. Okay, so that's how the periodic table is ordered. That's how we use it. It's ordered by atomic number. Periodic. Why is it the periodic table? Well, because things repeat periodically. Properties, specifically. Properties repeat. Okay, so something that comes up periodically, like Christmas, comes up once every year, periodically. So if you look at the periodic table and you start at one element, let's start at lithium, and then you go 1, 2, 3, 4, 5, 6, 7, 8. So it's important to remember that neon is really just 1 proton away from sodium. So if you drew it on a cylinder, they'd be connected. Cylinder. Like that guy, the green guy in the video we watched said. So you go 8 elements away, you're back at an element that has similar properties. And then if you go 1, 2, 3, 4, 5, 6, 7, 8, you're at another element with similar properties. These properties repeat periodically. Okay, and what subatomic particle causes the attributes of different groups? Electrons, specifically valence electrons. Okay, everything in a group has the same number of valence electrons, and that's what causes the properties. Because valence electrons, the outermost electrons of an element, the ones way out here, are what are going to interact with something else's valence electrons. They're the first things that are going to touch. They're the outermost things. Okay. Oh, this didn't copy in very well with the trends. Let me see here real quick. I don't know where my thing went. Okay, so you know what? Let me just end this video here. We've gone through about half of everything on here, so I will start the next video with the trends. Let me pull up a periodic table and everything because I was not anticipating it not being here. And so we'll start talking about that in the next one.